All right. So hello, everybody, and thank you for the opportunity to present. My name is Sanya. I'm postdoc in Los Alamos National Lab, and I will tell you today about how the EnPeel technology will be the next best thing in the plastic recycling. And of course, we all know that plastic pollution is a thing. We hear about it, we read about it from about every single outlet. And in order to really understand how to approach this problem, we first need to understand what plastics are. And plastics are products that are made out of polymers. And polymers are long chains of molecules that are built by linking the smaller molecules in a repetitive manner to one another. We call those monomers. And the monomers' chemical and physical properties may change. And as we change their nature, we change the nature of the plastic and of the polymer. And this is exactly how we end up with a variety of plastics. They can answer all of our questions. They can be resistant to water. They can be impenetrable to oxygen. They can be flexible, or anything really you can think about. And this is only if we talk about plastics 1 through 6, which is individual plastics and single products. If we touch on things outside of this range, those are the multi-layered plastics. And they're exactly what they sound like. Different types of plastics glued together into one single product. Think of a chip bag that we buy in a supermarket. So it's great until it's time to get rid of them. Then it's not so great because we really don't know how to do that. And overall, if we compare how much plastic we reuse versus how much plastic we produce, it's about 9%. So every time we go to extraordinary length to recycle one plastic bottle, there is about truckload that goes into the landfill to die. And we need to stop it. The problem, however, though, is that most of the recycling processes approach the recovery of the final product as the main goal. And this leads to the damaging to the product, downcycling it, and reduction of its value, which is why the plastic recycling in its true form can come only if we deconstruct our polymer to its building blocks or monomer, and then reconstruct them into a same product with the same properties without losing anything really. And this is where the EnPeel comes in. So think of an EnPeel like a railroad switchboard. The train goes, and now it needs to decide where to go. That's how the plastics behave because they have all the different properties and we need to recycle them as such. So the plastics from the solid waste and from the currently existing facilities such as MRFs, those are the ones that sort plastics and basically decide on their final destination. The EnPeel will receive it and catalytically deconstruct them appropriately to their chemical and physical properties, which means that we will end up with the pure monomers that can then be reconstructed into the plastics that we all love and use every day. The way we do this is with enzymes. Enzymes are biologically derived catalysts. They are perfect for this task because they work specifically on the specific chemical structure of the substrate or the plastics in our case. They're not very stable under harsh conditions, which is why our technology encapsulates them in a cage that makes them stable under the increased pressure or temperature or stuff like this that is necessary for deconstruction of plastic. In our way, if we give an example, the multi-layered plastic or contaminated plastic, such as, for example, in here, PET and polypropylene, those are plastics 1 and 5, come together. They cannot be recycled today. With our technology, we expose it to the enzymatic mixture and it peels the layer away. It peels the PET as the monomer and keeps the polypropylene and polyethylene as completely intact polymer that can then be reshaped. Our advantage is, of course, that we can definitely tackle those plastics that no one else can tackle today, but yet it's the mostly produced ones, such as a polypropylene and polyethylene. We do add value with our process by producing both the pure monomers and highly virgin quality pure plastics and polymers that can be reincorporated into the currently existing markets. We definitely address directly the multi-layered plastics that are not addressed today at all. And we allow to take the dirtiest, the most unwanted parts of the trash and make them valuable. And we do believe that the time is now, and companies are starting to emerge all over the world. Companies approaching it through all the different types of technologies. However, most of them, again, concentrating on recovering the plastics in the highest purity. And we are coming up with a completely new approach, and we will pretty much be somewhere here where we'll be recovering the monomers in the pure plastics and allow chemical recycling industry to grow even further. One other advantage for our technology is that we are US based. Most of the companies are emerging around the Europe, Canada, Australia, and US is only now joining the game. But the time to join it is now, because most of the huge producers of the plastics, such as IKEA and Coca-Cola, Shell, you name it, they right now pledge to the sustainability, and they're willing to put money and commit and really push the development of this technology even further. We are tackling specifically the North American market, and we're not touching the European one, and we assess it to be about $120 billion. And if we look even closer into this distribution of the market, we look that the majority of it as a whole chunk comes from monomers and intermediates of about $56 billion. And this is exactly where our technology fits in. As I've mentioned before, the new startups are starting to raise capital and starting to develop. In the past 2 years, the most of them have been established and started growing. The early technology providers are now starting to operate profitably with higher margins as they mature and scale. And the investors have started looking at this technology more favorably as compared to 3, 4, or 5 years ago, which is a really good thing. Our business model is, of course, collecting the most unwanted waste from the municipalities or companies that deal with the waste treatment, separate them in our facility with the EnPeel technology, where we peel each layer into the valuable product. And then whatever we get left with, be it the pure polypropylene on the monomers that we get from the PET layer, for example, can then be sold to the plastic producers today and be incorporated in the currently existing technology. Keep in mind, the plastic producers don't really care where the virgin polymer or the monomer comes from the fresh petroleum base or from the recycled product. We're pretty early. We are right now applying for grants and developing our IP portfolio and doing the customer discovery, which is going really well from what we think. When this is complete in 2022, we aim at specific and targeted enzyme selection and encapsulation. And in the following 2 years after that, we plan to come out with the impressive demos, both on the lab scale and on the large scale. And of course, we are always in search, and specifically now we're in search of collaboration and partnerships. We do believe that the true progress is made through the collaboration, both in academic and industry. They both contribute valuable information and knowledge to the development of the process. And of course, as Los Alamos National Lab, we're not particularly equipped to the large scale testing. And this is the project that will require that. And we are in search for partnerships from industry. Right now, we have a positive feedback from Rio Grande Recycling Corridor, which is a local consortium of plastic recyclers in New Mexico. And we are discussing the opportunity for polypropylene supply with a company, PureCycle, which is a small company in Ohio that would like to grow beyond one plant, and not being able to take advantage of polypropylene that's being discarded is kind of a drawback for them to grow. And with that, again, thank you for the opportunity. Feel free to reach out, and I'm waiting for you in our break room today at 12. Thank you.
Thank you. Thank you, Tatyana. Really appreciate that. And I'll turn it over to Mike and Joey if you have questions.
Yeah, Tatyana, hey, this is Mike. Sorry, Joey jumped in there ahead of you. Hey, just a question for you. You on the competitive matrix that you showed us, you didn't really differentiate, in my opinion, at all how you're different from these other competitors. And when I think of what differentiates you as one question. And then second, you've got quite a long development timeline. I guess I just wonder if you can bring this technology to market quick enough and not get beat by others that are already, either early in the market or in the market already. Just kind of what are your thoughts there?
Our thoughts are that with the right investment and the right team, we can be in the market reasonably quick. I think it's been demonstrated time and time again, specifically with bio-based tech, that when you put the right team together and you flow enough capital on it, in 11 months you have a vaccine, and 29 months you have device. So we can definitely go there sooner. The only question is whether the investment will be there to make us really, to make it possible for us to go sooner. The technology is on the surface. The technology is tested on different processes and not in plastic recycling necessarily. So we do know that the technology works. Right now, we just need to find an enzyme specific to us, which again, we have it down selected already to a number of enzymes we just need to test, and we can take it from there. The difference between us and the different competitors is that only one growing company in Europe is approaching the depolymerization through the enzyme. The rest are concentrating on isolation of the polymer and not the monomer. So we are different from almost all of the competitors that we put out there. If that answers the question.
Well, let me let Joey jump in because I think I have a follow-up question.
Okay, well, my question is pretty quick. Actually, I was listening to NPR podcast, Planet Money, the other week about recycling, and one of the problems that they talked about in the recycling industry is that it is just way cheaper to produce new plastics than it is to recycle. Given that we are a profit-driven society that doesn't really like thinking long-term, how do you make the economics work?
So what they say was true until recently, because it was way cheaper to discard plastics, load it on a ship and ship it primarily to the Asian countries who were buying that, and it wasn't a problem. Now that stopped. China, Taiwan, and those were the major buyers of the plastic waste. They ended it. I think it's translated as a national sword, the thing that they called it. And right now the plastic can no longer be shipped anywhere, and it needs to be dealt with locally in the US, which automatically brings some aspects that people were not thinking when they did not consider recycling as an option. Also, the technologies such as chemical recycling that were not cheap and were not advantageous 10 years ago are not that way today. We've made progress. We can definitely demonstrate that we can operate at much cheaper costs and energetically more favorable, let's say money-wise. So we are much better at recycling today than we were 3 or 4 years ago. And we do have larger issues right now that didn't cost us money 5 years ago that do cost us now. So the cost assessment of the recycling versus the production from the petroleum is not necessarily correct today with the data that was collected 3 years ago.
Thank you.
So Tatyana, I think just I want to go one step more. Joey's question was getting at, I think a thought I've had is seeing your presentation as cost. And have you done, for example, a techno-economic analysis to try to get to the question Joey's asking about what the likely hard costs are going to be for your technology relative to landfilling? I mean, have you gotten to that point in your analysis yet?
Not to the final point. Since the technology is very early, we need to assess costs, for example, for the production of an enzyme on a large scale. And until we know that, we cannot accurately assess the cost versus the landfill. We do know what it costs to landfill it. We do not know what it costs us health-wise and land loss-wise when the plastic migrates and deems large areas unworkable and water undrinkable. So this is something that needs to be incorporated in price of the landfill as well. And this is not yet done by the world organizations. So we're working on it. The assessment is not as straightforward. We started to tackle it. We're not there yet due to the TRL that we're at. Yeah, I guess that's all I have definitively at the moment.